Hey guys, it's Mr. Duffy checking in, and it looks like you've gotten to the point where you have to start to make your model of either the tuna can shaped kitten or the long soda can shaped kitten as far as their lying positions. And also you have to start making your expressions. So I'm going to demonstrate how you might start to make that expression. Starting with our tuna can shaped kitten over here. I'm going to show what kind of prism we might want to make. Get rid of this guy over here, expand this guy. Good. Alright, so if he's laying in the shape of a tuna can, the top of a tuna can is going to be a circle, and it's going to look like an oval because of the positioning of the cameraman. And down here, and then of course you can't see the back. And we've got our tuna can, my poorly constructed 3D drawing of it. And let's just say that we've got another tuna can. Because we can't use circular shapes because of the wood that we're using. We have to make sure that it has edges. So I'm going to draw another cylinder that looks like this. And we have to make a prism that goes around this cylinder. So let's just say maybe it's a rectangular prism. And I'm going to draw it just like this. So this cylinder would fit right inside of our rectangular prism. Of course, you can't see that backside. Just like that. Alright, so that's a poor version of it, but as you know, this is a rectangular prism. And what I want to know is how do you find the surface area of this rectangular prism? Well, how many surfaces are there? Well, let's look. The front one is one surface. The second one might be the bottom. The side right here is 3. The top might be 4. The back would be 5. And the left side might be 6. Looking at this prism one more time, we've got our length out in front. This right here is our length. Right here, this is our width. And then our height is how far it goes up, as we know. All right, so to find the surface area, of course, we have to find the surface of the area of every surface. So to find the area of side number 1, you're going to take the length times the height. Surface area of side 2, that would be the bottom. So we've got this area right here, and that's the length times width. Then the surface area of side 3, that is the width times the height. Four would be the length times the width also. 5 would be the length times the height. We've got the length back here and the height. And then the 6, sorry, that looks like a G. That is the height times the width, or width times height. Find the total surface area. You find the sum of all these smaller surface areas. Sum means add. all these surface areas. Now, you don't have to use a rectangular prism. You might be able to use a pentagonal prism or anything, or a hexagonal prism, or octagonal prism. Choose some sort of prism that would fit around the outside of this cylinder. If we look and we see that the cylinder has a circle at the edge, I'm going to draw another circle here. If I come back here, another terrible circle. You saw I made a square or a rectangle around it, but you could also make a triangle around it. You could make a pentagon around it. You could make a hexagon around it. It all depends on what you want to do with this. And remembering that we are trying to make it so that the smallest surface area would be optimal. So think about that. Think, how many edges could this take to make an optimal or minimized surface area?